So you end up with a solid joining to two other solids in that particular eutectoid composition of about 0.8% carbon. I mean, sometimes it's 0.77, sometimes it's, it can depend on how you actually austenitize the material at very high temperatures. So usually when we work a problem, particularly on an exam, 0.8% carbon, a little easier to work with. Okay. So what is the microstructure when you cool to something like 730 degrees centigrade? Well, of course, to answer that question, you have to know what the eutectoid temperature is. And the eutectoid temperature is 727 degrees centigrade. So if you only cool to 730, you'd still be just above this, right? And it would be single phase, all austenite. So let's look at 730 degrees centigrade, a 0.2% carbon steel would be base center cubic. So, because the composition of this 0.2% carbon has continuously changed as you cool it and follows this curve here, by the time you get just about to that point, the remaining austenite, I mean, obviously this is alpha plus gamma, as you cool down through here. The remaining austenite is just about 0.8% carbon. So you can use the eutectoid reaction to figure out how much, what the composition is and how much of the ferrite and carbide occur. So let's look at first what happened. The ferrite that's come out has a 0.022 weight% carbon content. And so we can use a lever rule, for example, to say, what is the amount of pro-eutectoid ferrite? Alpha. Which happens to be BCC, by the way. And you should know that gamma is FCC and alpha is BCC. And for all that matter, alpha prime is body-centered tetrafragonal because of the distortion of the lattice due to the carbon content. All right, so the amount of pro-eutectoid alpha. It's called pro-eutectoid because it's coming out before the eutectoid reaction. And if you were over here and had a hyper-eutectoid steel, you could have pro-eutectoid ferrite, iron carbide, Fe3C, coming out before this decreased along here to the eutectoid composition. All right. So we can use a 0.022 A and a fulcrum here at 0.2 because we're talking about a 0.2% carbon steel. And out to here, we're going to call this AB, B prime is at 0.8. Okay. So the amount of pro-eutectoid ferrite that's coming out is going to come out as we cool down through here because it becomes more and more alpha. The alpha is lean in carbon, and so the gamma becomes rich in carbon. So the amount, the percent alpha is going to be just like EB prime over AB prime. So the whole thing is AB prime, and the opposite part of the lever is BB prime, which indicates how much ferrite's coming out. So percent alpha, this is proeutectoid, is going to be 0.8 minus 0.2 all over 0.8 minus 0.022, and that comes out to be 77.1% proeutectoid alpha. Now, that's the amount of alpha that's outside of perlite, because when you then continue to cool this down below 727 degrees centigrade, you get eutectoid reaction, which is Fe3C, and then additional alpha comes out. And so you have proeutectoid alpha and alpha that is in the eutectoid composition, which is called perlite. Okay? So the rest of alpha comes out below 727 degrees centigrade in the perlite, which is alpha plus Fe3C. So you get these Fe3C long thin carbides in an alpha matrix. Question? What's that?